How do deep-sea creatures survive ocean pressure? Imagine swimming in a world where the water presses down so hard it could crush anything not built for it. That's the environment deep-sea creatures live in every day. How do they manage to survive under such intense pressure? Well, it all comes down to their special adaptations and unique body features. First, most deep-sea animals don't have air-filled spaces like lungs or swim bladders. These spaces would collapse under high pressure, so these creatures evolved to avoid them altogether. Their bodies are mostly made of water, which is incompressible, meaning it doesn't change size much when pressure increases. This makes their bodies naturally resistant to the crushing forces of the deep ocean. Another key adaptation is the structure of their proteins. Proteins are the building blocks of cells, and in deep-sea animals, these proteins have special shapes that stay stable under extreme pressure. Some proteins have larger or smaller cavities inside them, which helps prevent them from being squished or losing their function. This way, their cells can keep working normally even thousands of meters below the surface. Metabolic adjustments also play a role. Enzymes, which are proteins that speed up chemical reactions in the body, are less sensitive to pressure in deep-sea animals. This allows their bodies to keep producing energy and maintaining life processes despite the crushing environment. Some fish living in the deepest parts of the ocean, like the Hadal zone, have fewer bones and more flexible bodies. This reduces the structural stress caused by the immense pressure. For example, the Hadal snailfish has evolved to survive in areas where pressure can reach over 1,000 times what we experience at sea level. There are also organisms called piezophilic, or pressure-loving, creatures. These organisms thrive in high-pressure environments because their proteins and metabolic pathways are specially designed for it. They are like the champions of the deep, perfectly adapted to their extreme surroundings. Studying how these animals survive helps scientists develop new materials and enzymes that work under high pressure. This knowledge can be useful in medicine, industry, and even space exploration. Understanding their adaptations shows us how life can flourish in the most unlikely places on Earth. So, deep-sea creatures survive the crushing pressure by having bodies made mostly of water, special protein structures, and metabolic systems that are built for extreme conditions. These adaptations let them thrive where most life would simply be impossible.